All right, so this is kind of the culmination of all the factoring we've been doing, okay? This is probably maybe a little bit more difficult than we've done before, but we've gone step by step. We've worked our way up to this point, so you should be prepared for what we're going to do today. It's really not a whole lot harder than what we just finished doing. What we did before, we factored a second degree polynomial when a was equal to 1. So when I say a, these polynomials kind of look like this: ax squared plus bx plus c, all right? So when I say that a is greater than 1, up to this point, this right here has only been a 1. Now, on the worksheet that I gave you, there was a few where it wasn't a 1, correct? That's the thing you did yesterday, right? So, but yesterday, you were able to factor out a common factor. Today, you're going to have a number here that's not a 1. It would be a 2, a 3, a 10, a 12, or whatever it is. I don't know. And you're not going to be able to factor out a greatest common factor like you did in the worksheet. Okay? So even though technically we did a couple where a was greater than 1 yesterday, you could always factor out the greatest common factor. Today, you cannot. So we're going to be stuck. We're going to be like, well, what do we do if we can't factor out a greatest common factor? Well, I will show you. All right, we're going to start right with an example. They don't give you any like lead up or anything like that to it. They jump right into the example. And they just show you how to do it through this example. So they ask you to factor this. So it's going to be 2x squared plus 5x plus 3. Now, there's kind of an old-fashioned way, and for years, really, when I was teaching, I would teach just kind of guess and check. Nobody told me. I don't remember in college. I don't remember in high school. I don't think anybody told me how to do this because I think I would have remembered because it's a lot easier. But don't write this part down right here. Just watch, and then I'll tell you when to write. So what we would do is we would put two things down here. Remember, the first one has to equal what? This one and this one has to multiply to equal what? 2x squared. Just the 2x squared. Just this one right here. Okay, that number right there, right? And this number right here. Remember, we got two numbers in here, right? So the first ones, remember, first, outside, inside, last, right? So the first ones, the first two, have to multiply to be what? 2x squared. All right? Well, what it used to be, it was just an x squared. So you put an x and an x, right? Easy. No big deal. But this time it's a 2x squared. So one of these is going to be what, do you think? A 2x, and the other one's going to be a 1x, okay? Now, here's the deal. This last one and this last one right here have to multiply to be what? 3, right? First, outside, inside, last. The first multiply to be the first term, right? The last multiply to be the last term. So this needs to be a what? Well, it could be a 1, or it could be a 3. This would be a what? A 3 times 1, or a 1 times 3. Depending what order you put it in could change it. All right? So let's try... let's try 3 and 1. This is kind of a guess and check method. Now, the numbers on here are relatively small, pretty small, so there's not a whole lot of guessing we have to do. There are some, though, where the numbers are a little bit bigger, and there's all kinds of choices that you can have, and guessing and checking could take forever. You might guess correctly the first time and get it right the first time, or you might take 3, 4, 5, 6 different variabilities or different choices to get it to work. That's why it's not the best method. I'm going to show you a better method, but you could do it this way. How do I know if that works or not? Yeah, do the FOIL. That's right. So 2x times x is 2x squared. So far, so good, right? What about the outside and inside? The outside would be what? 2x, and the inside would be 3x. What's 2x plus 3x? It's 5x. So that does work, doesn't it? So we kind of got lucky. Well, there's really only two choices here. But we kind of got lucky the first time. What if I would have chosen a 1 here and a 3 here? Will that give us this? Now again, the first and the last will always multiply to be 2x squared and 3, right? It's the inside ones. The outside and inside have to add up to be 5. Let's see if that happens. I got 2x times 3. That's the outside. What's that? 6x. And then I got 1 times x is 1x. What's 6x plus 1x? 7x. Is that a 7x? No, it's not. So is this the correct factoring? No. So the first one, right? And we kind of got a little bit lucky. And we chose a 3 and a 1 that actually worked. Okay, but this does not work. Does it make sense? So on something like that, it really wouldn't take that long to actually factor it. But I'm going to show you a surefire method that's going to work every single time. Okay? Everybody with me? So here's what we're going to do. In order to factor this, first of all, we're going to look at that number and this number and multiply those together. What is that? No. Just, I'm sorry. The number out in front. Sorry. Yeah, the number out in front. So 2 times 3, which is what? 6. Okay, now what I'm going to do is I'm going to take that number 6, and I want to see, and we're going to do what we basically did yesterday with the regular second degree polynomial factoring. So what I'm going to do is I'm going to say what times what is 6. So we only have two options. What do we got? 1 times 6 and 2 times 3. Would you agree? All right. Now, what we're going to do is look at these two. Which one of these will add up to 5, the middle number? The 3 and the 2. That's right. Everybody with me on that? Okay, so now watch. Remember we did grouping just the other day, like 2 days ago? We did factor by grouping. We're going to actually incorporate that here. So this is what I'm going to use right there. Because 1 plus 6 is what? 7. So 1 plus 6 doesn't work. I'm not going to use that. But I'm going to use the 2 and the 3. So here's what I'm going to do. I'm going to make that 5, because 2 plus 3 equals 5. I'm going to break that 5 down into 2x plus 3x. Does that equal 5x? Yes. So watch what I do. I'm going to keep that the same, not going to mess with that. I'm going to rewrite 5x, but how am I going to rewrite it? With these coefficients. So plus what? 2x plus what? 3x. Do you see that? Would you agree that that is the same exact thing as that? Yeah. And then we just finish off the rest of it, put a plus 3. Now we can factor this by grouping. We just learned how to factor by grouping just 2 days ago. So let's do it this time. Remember that? We're going to group those together. We're going to group these together. And then, just this grouping right here, there's a greatest common factor here, isn't there? What's in common with both of these terms right here in that parentheses? A 2x. So we factor out a 2x. What's left over after we factor out the 2x? Well, it's 2x squared divided by 2x. What's that going to give us? 2 and the 2 cancel. X squared divided by x is just x, right? Plus, because of that plus. Now I go 2x divided by 2x. What's that? It's a 1. You with me? Okay, put this plus sign now. Now, what's in common? What's the greatest common factor of these? Just a 3, right? Let's factor out a 3. If I take a 3 out of this, what am I left with? An x. Take a 3 out of this, divide it by 3, what am I left with? A 1. Everybody good? It's not yet, because this is a plus, so it's not they're not being factored. Okay, I don't have something just times something else. I got these two times each other, I got these two, but this whole thing is being added to this whole thing. So it's not a factor yet. Okay, they're not factors. But they do have something in common. What do they have in common with each other? An x plus 1. So I'm going to put an x plus 1 right here, and let's factor it out. If I take this and factor out an x plus 1, what am I left with? 2x. Plus, if I factor out an x plus 1 from this, what am I left with? 3. Now I'm done. Now I have one thing multiplied by another thing. This parentheses times something else. Now they're factors, aren't they? Okay, now they're two things that are being multiplied together. And now I can circle it, and that would be my answer. Isn't that the same thing I got when I guessed and checked? It is. Okay, let's just check to see if that was right. Let's do a little FOIL here. What's x times 2x? 2x squared. Let's do the outside and inside. The outside, x times 3 is 3x. The inside is 2x. What's 3x plus 2x? 5x. That works, doesn't it? And then the last, 1 times 3 is 3. So it does work. All right, and there you go. You did your first factoring with a greater than 1. Does that make sense? Do you see how you use the grouping that we learned that earlier, right? You learned it earlier and you put it into practice. We knew how to do this thing right here with our other factoring problems, and we put that into practice. So we basically just took two things that we learned previous this week, or is it this week? Maybe last week was grouping. Maybe last week was grouping, yep. But we learned two things, and we put them together to do this one particular problem. This is something I did not learn, believe it or not. I didn't learn it until several years after I'd been teaching, all right? Didn't learn it. So you just guess? I would just guess. You would just put a bunch of numbers in and see which ones worked. Sometimes they were educated guesses, right? But yeah, a lot of times you just guess. Now, this was pretty easy to guess, right? If I messed up the first time, I tried one more option. That's the only option I had, and it worked. Boom, I'm done, okay? But this works every single time, right? And you don't really have to do a lot of guessing, right? This isn't really guessing, but it's just seeing what multiplies together and then see which ones add up to that middle one. I wouldn't consider that guessing, but some people might think of it as that. Let's do another one. Now you got the hang of it. Now you kind of see what we're doing. So let's do example 18. It's very similar with one little twist. And we've done that little twist before, okay? It's nothing that we haven't done. So it's nothing really new. But we're just putting a couple things together that we've learned previous, putting it into one problem. All right. Now again, you got a number out here. Is 2 a common factor? Can I factor out a 2 from everything? No, because that doesn't have a 2 in it. That does, but not all 3 of them. So I can't factor out the greatest common factor. So I got to do it this method, okay? This is a polynomial, right? It's a trinomial factoring when a, right, the letter out in front, is bigger than 1. Everybody got that? All right, so we've got to do that method. What was the very first thing? Look in your notes. What was the very first thing that we did on that last problem? Look in your notes. Not yet. By? Not by each other. By the 6, right. Remember I did this? And you said 2x squared, and I said, oh, sorry, I should have been more specific, and I circled that. And we will. I am not going to deal with the negative just yet, okay? I'm just going to go to the 2 times the 6. Okay, we'll incorporate it in a minute, all right? So what did I do? I went 2 times 6, which is what? 12. So now what I'm going to do is I want to find out what multiplies to be 12. Hey, listen. What two numbers multiply to be 12 and at the same time add up to what? -1, because there's a 1 right there. You with me on that? Yeah, you could just think of it in your head. It's not that hard, okay? 12's not a hard number, but let's say you really couldn't think of it in your head. What do you do? What steps do you do? You just do all the factors of 12. Start with 1. 1 times 12 is 12, right? I don't need to put equals. 1 times 12 is 12. What else? 2 times 6 is 12. What else? 3 times 4 is 12. And then 4 times, and I just start repeating it again, don't I? You with me? So, you already said it, and you probably see it already. Which one of these, now remember, this is a -6, a -6. That means when I multiply them together, one's got to be positive, one's got to be negative, okay? That means we're going to actually do a subtraction. So which one of these can I get a -1 out of if I subtracted? What about 1 and 12? If I subtract those, any way I can get a 1 out of that? If I add or subtract? No. What about 2 and 6? No, there's no way I can get a 1 out of that. What about 3 and 4? Absolutely. Now, if they add up to be -1, which one of these has to be the negative? The bigger one, 4. So it's got to be 3 times negative 4. Does that make sense? So what does this mean? That means it's 3x minus 4x is what? Negative 1x. Right? Yeah. Okay. So now what we're going to do is we're going to change that negative 1x into what? 3x minus 4x. But we got to be, this is where sometimes it gets a little tricky. You'd think you'd put just 3x minus 4x, but when I factored, I'd have a 2 and a 3 next to each other. Is there anything in common with 2 and 3? No. So which one do you think I'm going to put first? I'm going to put the 4x because 2 is in common with 2 and 4, and 3 is in common with 3 and 6. Make sense? So that's why I'm going to switch it that way. So watch, I got 2x squared. Again, how do I rewrite this? I'm going to write it negative 4x plus what? 3x. Do you agree that that equals negative 1? Yes. Yeah, that's all we did. All we did was just rewrite negative 1 so that it's this, and then I can group. And then you just put a minus 6 at the end. Do you understand why I didn't put the 3 first? Because if I did, I got a 2 and a 3 here. I wouldn't be able to factor out a common factor. That's why I put the 4 first. Because, yeah, 2 will go into both of these. 3 will go into both of these. All right, so that was a little bit tricky. So now let's go ahead and factor. So I'm going to do it by grouping. I'm going to group those together. That's a plus, which makes it pretty easy. I don't have to change any signs or anything. So I just put them in parentheses. Now, what's in common with both of these? A 2x. Not just an x, but a 2 and an x. If I took this and divided it by 2x, what am I left with? Just an x. Minus, take this 4x and divide it by 2x. 4 divided by 2 is 2. X divided by x is 1. So we get a 2. You watching? Yeah. Plus, now what do we do here? Factor out a 3 from both of these. If you factor out a 3 from this, you're left with an x. Put a minus. If you factor out a 3 from this, 6 divided by 3 is 2. And there you go. And look, you got a common factor here now, don't you? Right? It's always going to work like that. So I factor out an x minus 2. And what am I left with if I factor out an x minus 2? 2x here plus what? 3 there, and there you go. You could have just started with this and just tried a bunch of numbers, right? But look at all the possibilities you would have. You would have had a 1 and a 12, or a negative 1 and a positive 12. Let's keep count. Negative 1, positive 12. Positive 1, negative 12. Okay? You could have had a positive 2, negative 6, or a negative 6, positive 2. None of those add up to negative 1, do they? But if you just guessed and checked, that's 4 possibilities right there. And then you finally try 3 and 4. So you're going to try like 5, maybe 6 times before you actually get this if you just guess and check. You agree with that? So this is a lot better, all right, because it works every single time. All right? Boys? Amir? Landon? You good? Come on, everybody else got their heads up. They're all watching, participating. That's all the examples they have in the book. I found another example of something that I wanted to show you because you might encounter this in some of the problems. This has got one little extra thing with the sign that's a little bit tricky. So we're going to do this one. So this is an extra example. It's not in the book, but here we go. This time we got a 3 out in front. 3x squared minus 8x plus 4. Now again, you could just sit there and put 2 parentheses and then try a bunch of numbers. But you're going to have a lot of options, and it's not the most efficient way to do this. You might guess the first time and get lucky and get it right. So what are we going to do first? What's the first thing we do?
Multiply the 3.
Yep, multiply the 3 and the 4 together, which gives us, I'll do this, 3 times 4 is 12. So what I'm going to do, we already did this once. We did it in the last problem. But list all the factors of 12. Actually, let's not do that just yet. I'll do it in a second. But in your head, what do you think multiplies to be 12 and is going to give you an 8? You got a 2 and a 6. Right, 2 and a 6 will give you an 8, won't it? Okay? So you could just go with that. You follow me? So do you have to list all the possible factors? You don't, but sometimes it's helpful. So we'll do it for right now, but if you just wanted to put them down, you say 2 and 6. All right? Does that make sense? So let's just list them. 1 times 12, 2 times 6, 3 times 4. All right? Now, which one of these? Now watch. When you multiply them together, it's positive. When you add them, it's negative. Okay? So that means both of them have to be what? Negative. All right? So it's going to be what? Negative 2 and negative 6. Does that make sense? All right. So sometimes it is helpful to list all the possible factors if there's not a whole bunch of them, right? But yeah, we kind of saw it already. Now, what are we going to do? I'm going to go 3x squared. I want to write this as either negative 2 plus negative 6 or negative 6 plus negative 2. Which one do you think I'm going to use? Yeah, I'm going to use the negative 6. Why? Because 3 goes into 3 and 6, right? So I'm going to put negative 6x. And then what? Minus 2x and then plus 4. Do you see why I put the 6 first? Because I can factor out the 3 and I can factor out the 2 from this. What's different about this one that we haven't done yet today? This sign right here is negative, okay? So watch what we cannot do. Don't do this. Well, you can do the first part. You can do that. Okay, but watch. A lot of people have a tendency to go ahead, don't write this. Okay, a lot of people have a tendency of doing that. But just by doing that, that actually changes. Because look, this is negative 2x. That's okay. But what's this now? No. What's this? No. It's negative 4 because that negative's got to be distributed through there. Is that a negative 4? No. All right? You could do a couple things. You could just make this, watch this. You could just make that into a minus. Now, is this the same as that? Negative 2x? Sure it is. Right? We wanted negative 2x. It's still a negative 2x, right? Right? Because the negative 2x. But now it's negative 4, which is positive 4. So you could have done that. But that's not the way I taught you. I showed you that we could do this. Make this a plus. Let's push this over a little bit. Are you watching? This is a key. Okay? Everybody looking? All right. So I made that a positive, but then I'm going to make this a what? A negative. Is this the same? Yeah. I wanted a negative 2, and it's still negative 2. And I wanted a positive 4. It's still positive 4. You okay with that? That was a little bit tricky. So when that is a minus sign, you got to remember to do that step right there. That's why I purposely picked this example. They didn't give you that example in the book. All right, but you might have some problems where you're going to have to do that. Now, with that said, let's go ahead and factor. What's in common with both of these? We've done this a couple of times, a 3x, and what's left? X minus what? 2. Then you can put a plus, okay? Now, this is where you got to be careful also. What's in common with both of these?
Negative 2.
A negative 2 is in common. All right? We want to factor out a negative 2 because I want this to be just x minus 2. Everybody see that? So if I factor out a negative 2 from this, I'm going to be left with the x. Now, right, I factor out a negative 2 from a 4. 4 divided by negative 2 is negative 2. Remember, these have to be exactly the same. Okay? If I didn't do that switching of that negative sign, I wouldn't have gotten this to be the same. So you know, like if I got that to be x plus 2, I'm thinking, uh-oh, those got to be the same. I got to do something, right? So you go back, you look at your signs, you make your changes, and now you got this. Now this part's the easiest part, right? X minus 2 is in common with both of those. What do I have left then? I got a 3x and a minus 2. And this is your answer. If you wanted to double check to see if it works, okay, you can if you wanted to. All right, let's do it just for fun. All right, x times 3x is 3x squared. Let's do the outside. What's the outside? X times negative 2. Negative 2x. Let's do the inside. Negative 6x. And then the last, plus 4. 3x squared minus 8x plus 4. Yep, this does, in fact, equal what we started with, and it should. If it doesn't, you did something wrong somewhere. You either checked it wrong or you did the problem wrong. Make sense? All right. So I gave you 3 examples, and I don't think you're going to get anything any more difficult than those 3 examples on the homework. So here's your homework. It's R5F. F. This is our last one on section R5. Aren't you excited? It's page 57. All these have been on page 57. And you're doing 57. Oh my gosh, I hate to even write this. To 67. But you're only doing the odds. Yeah. What's that? This is being recorded, yes. All right, so you're only doing the odds. So it's not that many to do. And there you go.
What number are we doing?
I don't know. 57 to the other number.